Alright, hope everybody's enjoying their Sunday morning. Just wanted to record a quick video for AP Stats. So this is problem 2 on the problem set that is due on Monday. It says a large apple farm inspects random samples of its apples to make sure the batch is good enough for selling. It will reject the batch if it finds that 8% of the apples do not meet the standard. Suppose that in fact, so like we know, only 5% of the apples don't meet the standard. So they're telling us that. Now we go to part A. Inspector A selects a random sample of 100 apples from the batch. He will reject the batch if 8 or more of the apples do not meet the conditions. What's the probability this occurs? Be sure to check your conditions. Okay, so we have part A. It said Inspector A picks 100 apples, and he will reject if 8 or more are spoiled. And the probability that any apple is spoiled, this is important, folks. The probability that an apple is spoiled, they tell us that right here. In fact, 5% of the apples don't meet the expectations. So the probability of a bad apple is 0.05. That's the probability of a bad apple. So if 0.05 is the probability of a bad apple, right? Then we need to check our conditions. So the condition is NP is greater than or equal to 10. Let's find out. 100 times 0.05 is equal to 5. That is not greater than or equal to 10, so it fails the condition. Therefore, this cannot be approximated with a sampling proportion distribution. So we need to use the binomial. So use binomial distribution. So we're using binomial. The process is the same. We just had to check the condition. So now the question is, we want to reject if 8 or more are spoiled. So in other words, we want to do 1 minus binomial CDF of 100. That's the N. 0.05 is the P. 7. Because remember, this number right here tells us the probability that 1 is spoiled, or 2, or 3, or 4, or 5, or 6, or 7. If you do 1 minus that, then you have the probability that 8 are spoiled, 9, 10, and so on and so on. So let me do this. I'm going to go to my calculator here. By this point, we know how to plug in binomial CDF. So you go on this calculator, it is vars, second vars, binomial CDF. Total is 100, the p-value is 0.05, and the x value is 7, and we want to just paste that, and the probability is 0.8720. Now that's this. So this is 0.872040. You got to do 1 minus that. And the answer is 0.12796. That's the answer to part A. So again, on part A, we said he picks 100 apples. He rejects it if 8 or more are spoiled. The probability is 0.05. We did our test. We failed the condition, so we couldn't use sampling proportion distribution, so we used binomial. We wanted to reject if 8 or more were spoiled, which means we need to find, here's the probability that 7, 6, 5, 4, 3, 2, 1, or 0 are spoiled. Simply do 1 minus that, and there's our answer. Now what happens in part B? In part B it says, Inspector B wants to use a sample size large enough to assume a normal distribution. What sample size do I need to use? Well, if I want to have a normal, then NP must be greater than or equal to 10, and N times 1 minus P must be greater than or equal to 10. Remember, P is 0.05. So N, we have to solve for that, times 0.05 must equal 10. So N equals 10 divided by 0.05. So N equals 200. So if N equals 200, then N times P is equal to 200 times 0.05, which is equal to 10, so that's good. And then N times 1 minus P is 200 times 0.95, which is 190. That's good. So in other words, if N is 200, so 200 apples, then Inspector B can use a normal distribution. Why normal? Because then the conditions are met. And if the conditions are met, we say that the sampling proportion distribution is approximately normal. So 200 apples here. And finally, part C. Let's look at part C. It says Inspector C selects a random sample of 500 apples. What's the probability that he rejects the batch? Be sure to check the conditions. So N equals 500. We reject if 8% are bad. 8% of 500 equals 0.08 times 500, which equals 40. So we want to reject if 8% are bad. In other words, if we find more than 40 that are bad. Let's check the conditions. So NP should be greater than or equal to 10. N times 1 minus P should be greater than or equal to 10. And we should have random independent. Those are the 4 conditions. So let's check. So the first one is N times P. So N is 500. P is 0.05. Remember, the probability of getting a bad apple is still 0.05. This is the probability of getting a bad apple. That's still 0.05. Remember, that comes from right here. That's still the probability. So 500 times 0.05 is 25. So that is greater than or equal to 10, so we're good there. 500 times 0.95 equals 475, I believe. Yep, which is greater than or equal to 10, so we're good there. Does it tell us he uses a random? Yep, it tells us a random sample, independent, assume one apple does not affect another apple. So therefore, since conditions are met, sampling proportion distribution is approximately normal. Okay. Alright, so now we got this, right? And we got to push forward, do one last thing. So we checked our conditions. Now we just need to answer the question. What is the probability? Let's look back at the question. What is the probability that I reject the batch? Well, remember, N was 500. P, the probability of a bad apple, is still 0.05. And we reject if more than 40. More than, no, we reject it if 40 or more. Sorry, 40 or more are bad. Why is it 40 or more? Because it says reject if 8%, 40 or more are bad. So 1 minus binomial CDF 500, 0.05, 40. So here we go. Second distributions. Come here to binomial CDF 500, 0.05, 40, 0.998454, 0.998454, and we want to do 1 minus that, 0.001546. So this is the probability that Inspector C will reject. And again, how did we do that? We did binomials, CDF 500, 0.05, 40. By 40 is 8% of 500, and we reject if 8% or more are bad. This tells us the probability of having 0 bad apples, 1 bad apple, 2 bad apple, 3 bad apple, 4 bad apple, all the way to 40. We want to do 1 minus that. However, slight mistake here. Slight mistake. Notice the mistake I made. This should be 39, not 40, because we said 40 or more. So please note this is a mistake I made. This should be 39, not 40. So redo this one. This should be 39, not 40. Look, a classic mistake. I wasn't thinking. This should be 39 because we want 40 or more. So this should only go up to 39. So redo the calculations. Make this 39.997299. Not a huge change, but still a change nonetheless. Again, 1 minus that. 0.002701. This is the correct final answer. Again, make sure this is 39 because it says rejected if 40 or more. So 40 needs to be included in the rejection side. And that's the video for problem number 2. Let me know how I can help further.